developing what we call a thermal battery, and it's analogous to electrical battery. But the idea here is it allows us to store thermal energy in some effective way and deliver heating and cooling on demand. And in particular, this can be useful for various applications, one of which we have focused on is for automotive applications. So like electrical battery that, say, drives an electric vehicle, that allows the electric vehicle to run, then we also have a thermal battery that's used for the HVAC. And so in fact, it has advantages because you also charge the thermal battery like you charge electrical battery. And then when you're driving your vehicle, you can in fact save in terms of electrical power usage to extend driving range. And so the idea here is, well, the key to create an effective thermal battery then is just like your electrical battery, you need to have very high energy densities, so per weight and size, as well as high power densities, right, in this case. And so we've been developing also very similar to some of the other things that we've been doing is based on adsorption. So this adsorption-based thermal battery takes advantage of a refrigerant that then is adsorbed onto a material that allows us to now release heat in that process during adsorption. And so essentially what we have to store this energy, this thermal energy, is effectively a chemical potential difference when you have a wet refrigerant and a dry adsorbent. And they're separated by, say, a valve. And when you open up the valve, you allow the evaporation process to occur such that the evaporation gives you cooling in this case, and then you get the heating from the actual adsorption process when the refrigerant interacts with the adsorbent material. We've been exploring different types of adsorbents, one which is a very readily scalable and well-known adsorbent known as zeolites, which we've been able to tailor to improve the capacity to improve our energy storage capability. We've also been doing explorations with various types of metal-organic frameworks by which then you can tailor a little bit better because of the ability to actually modify these structures to capture more water to even further improve your capacity. We've also been working on delivering power densities that make it viable, and that has to do with now, because it's a thermal processes, it's transport limitations related to heat and mass transport. And so in that way, we've been incorporating kind of effective thermal binders with these materials because typically these adsorbents have very poor thermal conductivities such that the heat and mass transfer processes can be very slow. And so we've been creating carbon-based binders, other types of metallic foam binders to help us enhance the thermal conductivity and to ultimately realize these kinds of devices all the way from being able to tailor the materials, the kind of layers of these adsorption kind of layers to the actual prototype device or system. And so far we've been able to already demonstrate quite a few prototypes and being able to take advantage of some of these innovations at the materials and component levels to be able to realize a thermal battery that can be kind of implementable in next generation electric vehicles. This is also applicable not just for electric vehicles, of course, it's a thermally driven process, so this could also be very effective in hybrids, say HPVs as well as maybe even for what we use now, today, commonly the internal combustion engines. So certainly this kind of thermal battery concept is not just specific for vehicle or automotive applications or transportation. They could be tailored differently, say for your home, for heating and cooling of your home. If there are others, say for example, solar sources that give you heat, and you can actually recharge or operate your thermal battery that delivers your heating and cooling. And that could also be a very significant opportunity given the fact that heating and cooling in buildings are about, I think, utilize about 30% of the total energy of a building. And so this could be a viable option that essentially allows you to take advantage of many waste heat streams to be able to now provide your heating and cooling needs.